There's a specific kind of silence right before the world changes. It's that split second of realization, the moment when you know that life as you've lived it is about to become something entirely new. For more than 35 years, we've learned to recognize that moment. From Cambridge to the world, we partnered with our ecosystem, solving problems together. We've been here from the start of AI, preparing the world for what's next, powering intelligence everywhere, in how we live, work, play, and move. Together, this is our moment. Because when you know you have the power to change everything, you step forward. Please welcome Arm's Chief Executive Officer, Rene Haas.
Such a nice, warm welcome. Thank you. So welcome to our live stream audience watching the ARM Everywhere event. I don't think we've ever done a live stream event like this, and to the folks here in the audience, thank you so much for coming to the historic Fort Mason. And you may not know that Fort Mason here in California was actually an official defense site for the Civil War. And this is where a very famous battle between Alabama, Georgia, and California took place. Now you're thinking to yourself, I don't remember that battle. That's why this area looks so pristine. There actually was not a battle, but it actually was a fort. So I thought that was actually kind of neat. I didn't actually know that. So thank you again for attending a big day for us. We have a lot to share with you, so I'm going to jump right into it. When we thought about how to name this event and how to talk about our company, we thought ARM Everywhere was really appropriate, because one of the things that we're very proud of that we don't always think about in our daily lives at ARM, but is really quite impactful, is just the scale of the company and the scale of the magnitude we have. So when we start looking at numbers, 117 billion, what is that number? That's the total humans ever to live on Earth. So that's, if you count up by all of our calculations, how many people have lived on the planet since inception, about 117 billion. 350 billion plus are the number of ARM chips to have ever shipped. That is 3 times the total number of humans who have ever existed on the planet. So it's not just 1 for every human, it's 3 for every human that have ever lived. 7 times the total number of non-ARM-based CPUs shipped combined. Just think about that number. And 160 ARM chips for every global household. Mine is probably larger than 160, but 160 is about the average. So that just gives you a sense of the scale of what we've done, and it's really important because it feeds into everything that makes us what we are today, and of course, could not be done without our ecosystem partners. Now, the company's DNA was really born to run off batteries. The company started in the early 1990s. It was a spin-out of a British computer company named Acorn, And that company had a mandate to build a chip. And that chip had a couple of requirements. One was it had to run in a plastic package, which back then was really important. And number two, it had to be really low power. The first part was important because of heat. The second part was important because battery life meant everything, because this was going into the world's first PDA. So the company, we nailed that. We nailed that objective so solidly that, and this is a true story, that when the first ARM development board that had the first ARM1 processor was powered up, and these were plugged in now into a back of a wall. So you had a development board, lots of logic chips, plugged into a AC outlet. When the AC outlet plug was removed, the chip kept running. And the chip kept running based upon the leakage current that was coming off all the other chips on the board. So the folks came in the next night and they saw the oscilloscope was still driving a signal. And that is really what, for us, launched the revolution of smartphones. We were designed into the very first GSM phone, for those who remember that Nokia brick on the far edge. But then the BlackBerry, which many of us who had loved, still love, wish it came back, all the way to the modern smartphones of Android and iPhones. That is where we started in terms of the battery life. It launched a generation of smartphones. Now, one of the breaks we got about 10 years ago was when SoftBank bought ARM. Yeah, it was about 10 years ago. It was 2016. And when SoftBank bought ARM, Masa gave us an opportunity, now that we were a private company, to invest into areas that we were not able to invest in before. And that gave us the opportunity to expand the platform to a number of other verticals. We took everything that we knew about smartphones and then expanded that out into the cloud. We launched Neoverse. We got our first design wins in the data center. And then we were also able to invest into autonomous, automotive, physical AI. We could not have done that without that 2016 moment. And this is my thank you to Masa for allowing us to do that. We could not have made that all happen, and it's paid significant benefits for the company. However, as good as our products are, as competitive as the platform is for physical AI, for autonomous, for the cloud, it is really what I like to call the ecosystem of ecosystems that really differentiates us. And this is where the partnership really comes to life, because that mobile platform that we built cannot happen without the software. And the software layer in the case of the mobile area is iOS, it's Windows, it's Android, it's Mac OS. And then the litany of applications that not only run on the ARM compute platform, but they're highly optimized, highly tuned, and allows the partners in the ecosystem to build great products. That formula applies to every vertical that we participate in. It applies to what takes place in the cloud, whether it's Linux or OpenAI or Anthropic, and then the platform that runs with it. And this is why we like to call this the ecosystem of ecosystems, because it's not just one vertical. And you can see when we look at the physical AI platform with automotive, same formula. 22 million plus software developers that are very unique to a vertical, but they leverage a lot across the ecosystem that allows people to get started in other areas. So this is the magic, and this is what is uniquely ARM. This is what's very, very unique about our compute platform. There's no one on the planet who can serve the edge to the cloud in the way our ecosystem does. Now, over the past few years, we've been evolving our strategies, largely because we see the demands in the marketplace are around the chips are more complex, the cycle times to build these chips are getting longer. 5 nanometer to 3 nanometer to 2 nanometer means longer fab times, longer packaging times. There's a need to do more and to do it faster. We've traditionally provided IP in a standalone form, the CPU, the GPU, system IP, and that has served us well for the first 30+ years of the company. But as I said, we were starting to see huge demand for the need to go faster, make products better, and get time to market sooner. And we introduced something called compute subsystems. We did this about 3-4 years ago. We invested very heavily in terms of the engineering requirements to do this. And what this does is it takes all the blocks of IP and puts them together in a finished way, verified, performant, tested, that the end customer can then take to market. And in some cases, it shaves a year, in some cases 18 months off the time of starting design to getting into production. It was a very significant investment for us. We put a lot of effort and engineering into it. But we've already seen massive benefits in terms of the customer base. We introduced this 3 or 4 years ago. Our business model is a license plus royalty. Royalty is the laggard, so royalties start to show up 2-3 years after we license a product. Already, CSS represents almost 20% of our royalties and growing. Now that's our evolution. But of course, we're now in an era where everything is different than we knew it before. And when I think about artificial intelligence, and I get a lot of questions when I talk to analysts or media about, did AI just come up on us by surprise? And I think back to a time I was in Bletchley Park about 1.5 years ago, and the Bletchley Park is where the original crypto work was done by Alan Turing to help the West against the Germans in World War II. There's an area there where you can go in the museum and you see papers from Alan Turing about, can machines think? I think those papers were written in the 1940s. So the idea of AI is obviously not new. And if you're a sci-fi aficionado or fan, I certainly was growing up. Arthur C. Clarke was one of my favorite authors. 2001, A Space Odyssey. Now we have people who weren't even born in 2001 who are here. I always looked at this and said, of course this is going to happen. I just didn't think in my lifetime I would see it at the pace that we've seen it. And for anyone who says, this is a bubble and it's going to pass, it may be a financial bubble in the case of investment may slow down, and it may be an investment bubble in the sense of the valuations may not be what they are today, tomorrow. But if anyone thinks that this is something that is going to go away, it's a little bit of an ostrich syndrome. This is here with us. And it's really changed how people think about computing. However, somewhere along the way, people kind of thought CPUs were dead. And there was a thought that the only way you handle AI is through accelerated computing, that the CPU's role in the AI world is no longer relevant. Now, if we think about the role of the CPU and what happens in the cloud, now this is the cloud before AI, so I'm going to say it's before that last slide that I showed. Huge growth in compute cloud. We saw growth from AWS, Microsoft, GCP, and the conventional use of the cloud was you type in an answer, you do a search. Any seats left for the Warriors game? I think there are a lot of seats left for tomorrow's game, by the way, I have seen, or tonight's game. You got the prompt back. This is the cloud. Very simple, you do search, but CPU is very heavy. So when we look at the growth of SaaS 10+ years ago, 10, 15 years ago, and all the growth around cloud, the CPUs were doing literally all the work. Now, when you add the AI cloud, if you will, and now you are a human, and you're putting in a prompt into your device, whether it's your phone or your PC, well, of course, there are still CPUs involved. The cloud is servicing that request, and that request gets sent for a token, which the accelerator generates, and the CPU in that data center orchestrates and sends a token back. The token being a word or an answer that provides the request to the query. So this is all the work that's being done by the AI data center. So CPUs are involved both in the cloud, and obviously they're involved in the AI data center. And we estimate that in this data center, there's probably 30 million CPU cores per gigawatt. So there's a lot. And data center here is a combination of what sits right in the AI cluster, whether it's your head node to your accelerator, or what sits next to a dedicated rack. But the math is basically about 30 million CPU cores per gigawatt, okay? And that is the world that we've seen coming up to about the last year or so, or maybe even less. And what has changed in the last number of months has been this explosion of agents. Agents are essentially tools that act on a request and come back with a full flow of answers. So it's not just a query for an answer, but it's actually work. It's run a payroll task, do a scheduler, go off and write a number of analyses relative to a tool flow and provide me an answer. And we heard so much about OpenClaw here in the last few weeks as an example, and it's not the only example. Now, why is this important? Why am I talking about this? Because as we move to agentic query, the number of tokens per human go up by 15x, if not greater. And if you think about the why of that, it's pretty straightforward. Agents can generate requests, A, far faster than humans, and B, they don't sleep. They're at it 24/7. So the agents are now pushing these requests into the cloud, into the data center. And what's happening? The data center is choking. These accelerators, which are very expensive, that generate the tokens, now need to send those tokens back through the cloud. Now, if we think about what an agent is a workflow. As I said, it's a payroll task, it's a scheduler task. It's asynchronous. It is a lot of work relative to scheduling. That's what CPUs do. That is what CPUs do. That is not a work that can be done by an accelerator. The way to think about this is the accelerator generates the tokens, but it's almost like pushing a dump truck up, and someone's got to move all that dirt. The CPUs are the pieces of equipment that move that dirt, and agentic AI only increases that. So what you see is a huge bottleneck now in terms of flow. So what does that mean? You need more and more CPUs. Lots of them. CPUs near the head node, CPUs next to the accelerator rack, more CPU racks inside the data center, you just need more. And by our calculations, and we think this may be a little bit light, goes up about 4x, 120 million CPU cores for that same gigawatt, okay? So in that same profile, we now need 120 million CPU cores. Now, we're trying to put 4 times the amount of CPU cores in that same power envelope. Power is precious, obviously. The capital required for it is precious. So trying to put all those extra CPUs into a data center that is already stuffed to the brim with accelerators and CPUs doing the core work, that is a problem. Now, every tough problem needs a good solution, and we're announcing our first silicon chip that we are selling to customers for revenue, the ARM AGI CPU. Now, this is a big, big deal, and I would love to tell you every feed and speed about the product right now, but Mohammed will kill me if I do that. So we'll go into a lot of detail about the product and how we conceived it and the why. But let me be clear, we are now in a new business for ARM, and we are supplying CPUs as chips. The biggest reason we're doing this is that our partners have asked for it. But we're also really doing this to solve the problem I just described. As agentic AI becomes mainstream, all of the work required to make that happen is CPU bound, and you need a CPU that has the DNA of being born to run off a battery. So as I said, reason zero is our partners have asked us for it. And one of the partners we work the closest with on this is Meta. And I'm super pleased to have Santosh Janardhan with me today, who's going to do a better job than I can to tell you why Meta made that choice. Santosh.
Please welcome to the stage Meta's head of infrastructure, Santosh Janardhan.
Thank you, sir. Get the clicker. Hey folks, welcome. It's funny, every year I try to run the San Francisco half marathon, and they distribute the bibs the day before you run right here. I can tell you it looks very, very different compared to what I guess we are seeing now. So hi, my name is Santosh Janardhan. I lead infrastructure at Meta. So what does that mean? Well, it means that we traditionally go and custom build and design our data centers. We run it. We custom build our hardware, our GPUs, our CPUs, and we'll get into that quite a bit. The network that connects them, and obviously the software that sort of binds it all together. It's a fancy way to say that if your Instagram is not working, if your WhatsApp is not working, your message is not arriving, I am the person to blame. Okay? Now, if you think through our family of apps, that amounts to about 3.5 billion users that use our products daily. Every single day, about half of humanity logs into one of our apps and hammers away at it. And as you can imagine, that creates a decent amount of scale. We run a decent amount of the internet. And we're probably the only hyperscaler that's not a cloud, right? So if you think about gigawatts of capacity, tens of millions of servers, and increasingly, more and more, you're seeing bigger and bigger CPU and GPU AI clusters. Rene sort of went through that quite a bit. I think it's interesting to go and look at how this has grown over the last years. AI clusters are a fairly new thing, really started sort of post-COVID 2022, 23, just after sort of ChatGPT came along. And our initial clusters were pretty small. In fact, when I look back for this, in 23, our initial clusters were about 128 GPUs. That's it. But as you can see, even in 23, we started scaling quite a bit. And as you sort of fast forward, it really started growing. The demand for this has far surpassed sort of what any one of us could imagine it was. We are in the tens of thousands of GPUs stitched together in a single cluster now. And if I project it forward, and this is the thing I really want to set context, there is absolutely no sign of this slowing down. In fact, it's almost exponential. I only see it accelerating, right? So the demand is exponential, and as Rene was saying, power is constrained. I want to talk a little bit about some of our clusters. That is Prometheus. Prometheus is one of our bigger clusters. It'll surpass well over 1 gigawatt by the end of this year. That's a lot of GPUs, I can tell you. And we've stitched together a bunch of data centers, a bunch of tents. That thing you see, the blue colored thing, is actually a tent. It's a fancy tent, but still a tent, right? It's weatherproof. It can survive about a Category 2 hurricane. But we're putting together all of this, stitching it together with a network. And so to our developers, to our researchers, what they end up getting is about 1 gigawatt worth of an AI cluster in a single combined entity, which is pretty powerful, as you can imagine. But like I was saying, the demand is exponential, to put it mildly. That is Hyperion. Is going to go up to 5 gigawatts in a few years. Most people can't fathom what a gigawatt is. A gigawatt is about 10 Palo Altos. The town of Palo Alto, 10 times what it consumes is 1 gigawatt. This will be 5. That's 50 Palo Altos, right? That's what we are building out. So it's going to go and go really, really big. So why do we do this? At Meta, we have this vision of delivering personal superintelligence for every single one of our users. This means creating models that can go and figure out the most relevant experience, the most engaging experience for every one of you on our platforms. It means creating a personal assistant for every one of you, right? Now, if you have to go and deliver sort of personal superintelligence to billions of people, what kind of systems would that take? We're talking about billions of people, each using sort of exacting amount of compute over and over. And like I said, over 3 billion users a day, right? This, if this advances, there you go. So what does it take? Well, it takes power, it takes land, it takes a decent amount of hardware, software obviously, and most of all, it takes silicon, a lot of silicon, right? And this is why I think ARM is such a natural partner for us. What we want is a partner who can match our ambition, who can match our cadence of velocity of innovation. And what we realized when we were sitting down with ARM is that they could develop it, they were as hungry as we were, and most importantly for us, were as power conscious and as efficient as we wanted them to be. This is why, while ARM is now the primary co-collaborator and the primary sort of partner, the CPU that we are ending up developing is pretty foundational. It's not just a Meta CPU. It's not just an ARM CPU. This is something that I think will end up being a foundational CPU for the whole ecosystem. I think we are at the threshold of something pretty sweet here, because you're going to hear more and more about sort of the constraints that data centers are facing. You're going to hear more and more about, while the demand for compute is growing, the power is not growing at exact same curve. So this marriage I think about it personally as a win-win situation, right? So it's extremely sort of heartening to see ARM moving on from not just being an IP license provider, but actually getting into the game of sort of building something that is production scale and production ready. Exciting times. Yeah, you should. Yeah. 2 years, 3 years in the making, but I think about this as the sweetest things take some time, but we're getting there. Now, like I said, we are obsessed with efficiency. And if you think about one of the biggest appeal that ARM has had over the years, it's its power profile. ARM can go, Rene had this fascinating experience that he was talking about taking 30 million cores, instead of 30, now making it 120 million, and fitting it the same power envelope. But there's one thing, you don't want to compromise on performance. right? This is the thing that I really want to make sure we drive here. The biggest reason why we sat down with Arm and had this conversation was we want to put in a lot more cores per watt, but we do not want to compromise on the performance piece. That marriage is why I really think it's a win-win situation here. In fact, about 2.5 years ago, we sat down with Arm. We actually first surveyed the market to see was there a CPU that could meet the specs that we wanted. If we met the performance, we couldn't get the power. If we got the power, we couldn't get the performance. And this is why Arm ended up being such a partner. The ability to scale that Arm gives us when you push in a lot more cores. And if you think about personal superintelligence, if you think about the orchestration that Rene showed, you don't want to starve your CPUs, nor do you want to starve your GPUs. That marriage that you end up doing is, I think, that most people are going to realize pretty soon. Now, the design point that we chose for this was something to minimize risk for this iteration. We wanted to make sure we get our first CPU right, get it working out of the box. But this is a multi-generational partnership. I just want to emphasize this. When we look at subsequent iterations of things that are already in the hopper of what we're going to build out, I truly believe that this chip is going to expand sort of the performance on multiple axes. In fact, this ecosystem is actually going to be awesome. When you challenge the incumbents, you see innovation across the board. That, I think, is what all of us will end up achieving. Now, I want to talk about why. I want to take us back, I guess, to why we do this work. About, like I was saying, 3.5 billion people use our products every single day. This means that's your friends messaging each other on WhatsApp. It could be, a small or medium business messaging the users on a platform. It could be somebody going and doing an AI interaction with Meta AI. None of this is possible without infrastructure. Infrastructure has gone from being on the backside of sort of technology innovation to being the enabler of technology innovation, right? AI is built on the backbone of infrastructure. So every interaction, every post, every feed, every call is done on the basis of what we build out on the back end. And at least for us, we're custom building data centers, we're custom building hardware, and custom building silicon. That's why Arm, I think, is such a big partner for us. Because for us, we want to squeeze every bit of performance out of what we build out. We think about optimizing things like performance per watt, performance per gigawatt, and Arm allows us to do that. It allows us to go and increase the efficacy of everything we build out. Why? So that we can go and serve more users, so that we can go and hopefully improve every one of your lives in some way, shape, or form. And that's why I think Arm has been an awesome partner. So thank you, Rene and team. It's been absolutely a pleasure to work with you, and hopefully we'll do this for years together. Thank you. Thanks.
Wow. Amazing. Santosh, thank you. That was terrific. I have someone else I'd like to ask to join us to also talk about how they plan to use our ARM AGI CPU, and that's Kevin Weil from OpenAI. Kevin. Thank you, sir. Kevin, thanks for joining us.
Thank you for having me.
Welcome to Fort Mason. Have you been here before?
I have, for a few conferences in the past.
Yeah, well, welcome. So first off, just tell us and tell me, why does this launch today matter to OpenAI?
Well, I thought you did a good job painting this.
Well, thank you.
AI performance these days is system performance. And GPUs kind of get top billing wherever they go, but really the CPU is playing an incredibly important role as an orchestrator. But also I think as AI becomes more agentic, when you look at a rollout that an agent is doing, it's using tools inside containers, that's CPUs. It's running Python scripts as it performs skills. Those are CPUs. So the CPU plays an incredibly important role And it's really the whole system together that makes this all possible.
Now, your role at OpenAI is a pretty cool one, right? You're doing math and science and the stuff that's super compute heavy. And when you think about compute constraints, and I know when I talk to you or Sam or Mark or anyone at your company, it's, I need more compute.
Yes.
Tell us about that.
That is one of the most common things I hear inside OpenAI. I need more compute. It's kind of the coin of the realm. I mean, the root of it is we have more demand from customers. We have more ideas internally that we want to experiment with. We have more things that we want to do than, frankly, the industry can keep up with. And when you get to the bottom of all this, it's certainly about silicon, but it's also about power. And so if you have a CPU that can draw less power, it can be just as performant, but use less power. It means you have more left over for everything else that you want to do. That means more inference and more compute. That means more intelligence. And if there's one thing that I've learned in my couple years now at OpenAI, it's that more intelligence leads us to be able to build better products for all of you. The thing that I keep coming back to that I try and remind myself of all times is, as amazing as the models are today, and every year I'm blown away by the amount of progress we make, as amazing as the models are, the model that you use today is the worst AI model that you will ever use for the rest of your life. It's the worst AI model you're going to use for the rest of your life. And a year from now, you're going to be, you couldn't imagine coming back to the AI models of today because they're getting better at such a rapid pace, which just means there's basically infinite demand for intelligence. So we're not stopping from here.
And in your world, in your new role, where you're looking at verticals that are somewhat untapped today,
Yeah.
math and science and things of that nature, when you think about the ARM AGI CPU, or more broadly, what does more compute do for you in that space?
Well, I mean, the more compute you have, the more inference you're able to do, the longer the rollouts you're able to do. AI, as we go, as we're sort of progressing from this world of AI as chat to AI solving harder and harder problems. And just like you or me, when you solve harder and harder problems, you're going to need to think a little bit longer. So the more important problems we solve, as we start to think about things like enterprise AGI, science, you're going to need more compute, which means if you can draw the power that you have, which will always be finite, if you can draw that more efficiently, you can do more, we can solve more problems.
And for you personally, what are you most excited about, broadly, in terms of everything we see going on with AI?
Well, I mean, I think I have the coolest job in the world. I get to work on accelerating science with AI. And you've seen sort of a revolution in the past, even just 3 months, with GPT 5.2, 5.4, Codex. I mean, it used to be that people said, oh, well, these are just stochastic parrots. They're sampling from a distribution of data that they were trained on, but they can't do novel things. Now we're seeing every day AI solve open problems in science, in mathematics, in physics, in biology. We're seeing AI help us understand the nature of the universe. We're seeing AI work for weeks on end using a robotic lab to run 36,000 different experiments to optimize the synthesis of a new protein faster and better than any human could. So it's an exciting world. I think science is going to move faster than ever, and it's all built on the kind of infrastructure that you're providing here.
We are grateful for your support. Kevin, thanks.
Hey, thank you so much.
Thank you. I love the idea that the model that we're using today is about as bad as it's going to get. And that's crazy. I want to repeat, in case I wasn't crystal clear on the first go-around. We are now delivering IP, CSS, and chips. IP, CSS, and chips. Contact your local sales representative. Will is here. He can be reached afterwards. Now, seriously, I talked earlier about the ecosystem of ecosystems, and none of this could be done without the ecosystem that we have particularly around Neoverse. We have many partners that we work with on the supply side, whether it's around memory or connectivity. We've also got great customers who use our IP today, and they are so supportive of what we're doing. You know, Santosh talked about the demand. The market is so large, the demand is so significant that no one company can serve it. So what I'd like to do is, rather than me going on and talking about it, is have you hear from some of our partners and friends who I think you'll probably recognize a few.
Rene, congratulations on launching ARM's first data center chip.
Congratulations to ARM on the launch of the AGI CPU.
Congratulations on the launch of the ARM AGI CPU.
Today's announcement of the ARM AGI CPU is a significant milestone in AI-optimized compute and for the ecosystem.
Congratulations to the ARM team on the launch of an incredible milestone for the ecosystem built on innovation, scale, and openness.
The continued growth of the ARM ecosystem with its AGI CPU is a significant milestone in continuing to bring customers the flexibility to optimize for their specific workloads and ensuring accessibility of a new generation of purpose-built compute.
AI systems are evolving rapidly. They are becoming more autonomous and more data-intensive. And that means performance is no longer defined by compute alone, but by how efficiently compute and memory work together. ARM's latest platform opens new opportunities for system-level innovation across compute, memory, and storage.
We look forward to continuing our partnership with ARM to advance next-generation AI platforms and ecosystem.
We are proud to partner with ARM in building this open, scalable, power-efficient AI future.
Accelerated computing didn't make CPUs irrelevant, it made them essential partners. ARM architecture has become foundational across all of our platforms, from Jetson, our robotics system, to Drive, our autonomous vehicle system, our data processing units called Bluefield, to Vera, our CPU. Without the ability to mold and shape and modify the ARM ecosystem and the ARM platform, it's impossible for us to build these systems that we build. And so ARM's adaptability, modifiability, if you will, really has made it possible for us to integrate ARM across all of our platforms.
This collaboration with ARM has been great for both companies, and Graviton continues to provide better price performance for AWS customers. We see the AWS ARM partnership continuing to deliver big for customers.
We are excited about the opportunity this creates to expand the ARM AI and data center ecosystem. Our Azure Cobalt 200 CPU, built on Neoverse compute subsystem, is an important part of how we optimize and accelerate every layer of our stack, deeply integrating cloud-native capabilities and delivering the best price performance and efficiency across our fleet. Partnership with ARM is a key part of that vision.
We've been a long time and early adopter of ARM-based systems and a strategic partner in advancing the ecosystem. Having a diverse portfolio of ARM silicon and software gives OCI greater flexibility and differentiation.
Through deeper comprehensive collaboration in memory, foundry, SoC design, and advanced packaging, I believe ARM and Samsung Semiconductor can deliver exceptional ARM-based AI CPUs worldwide.
Google is proud to partner with ARM to support organizations' most demanding cloud-native and AI workloads.
This builds on a long and productive relationship between our two companies, working together across standards, technology, and products to help deliver the infrastructure for the world's leading data centers. We're proud to partner with ARM, and we look forward to building the next generation silicon for AI infrastructure.
We look forward to continuing our partnership together and to helping customers and users everywhere build AI systems that are smarter, faster, and more scalable. That's why our long-standing partnership with ARM is so important.
One seamless platform, from cloud to edge to AI factories. We look forward to building this future with you. Congratulations on bringing ARM's first data center chip to market.
Charlie and Matt and Sanjay and even my old boss did better than I could in terms of talking about this. But this has not happened without fantastic partnership and support from the ecosystem. Now, I know you are dying to hear about this product, as am I. And I'm now going to turn over to Mohammed Awad, who's going to tell you all about the ARM AGI CPU and why it is absolutely amazing. Mohammed.
Please welcome to the stage ARM's Executive Vice President, Cloud AI Mohammed Awad.
Thank you. Wow. Thank you, Rene. Thank you, Santosh. Thank you, Kevin. Thanks to all of you. Thanks to the entire ARM team that made today possible. We have been looking forward to this, and it is so exciting to be here. It's so exciting to talk to you guys. Thank you, thank you, thank you. Rene talked about how the world is transitioning from sort of legacy data centers to AGI data centers to agentic data centers, heading down this path, and how the CPU is at the heart of it. We've designed our AGI CPU around 3 simple principles. We believe that's the heart of what we're doing, it's the heart of what we focused on, it's the heart of how we think about it. First, performance. Performance, performance. With this many threads going on, with this much work to do, with this much orchestration to happen, you can't slow down. 24 hours a day, as Rene said, these agents are going to be running. And if they're not performing fast enough, then the rest of that infrastructure that's relying on it grinds to a halt. So we focused on performance. Second, we focused on scale. The scale of what we're talking about here is just incredible. You heard Santosh talk about gigawatts. Gigawatts. Scale at the CPU level, scale at the board level, scale at the rack level, scale at the warehouse level, all the way up. We focused on that. And finally, we focused on efficiency. Maybe most importantly. Because at the end of the day, with this much at stake, with this much compute we're trying to deploy, we're not going to get there unless we provide that performance, we provide that scale, and we do it in an efficient package. Those are the principles that have guided us. And we refuse to compromise. We've designed on all 3. Play the video now. I got to tell you, we are so proud. Our team has done a fantastic job on this, and it's really been designed from the ground up from this. Let me tell you a little bit more about what you just saw, because I know there was a lot packed into that video. ARM AGI CPU starts off with our standard Neoverse V3 compute subsystem. That's the same compute subsystem we make available to the entire ecosystem, and we have other partners building on it. Incredibly proud of that. We pack in 136 of those cores, which are very high-performant cores designed to be high performance. Our V-series is our most performant line, and you've seen it set records across lots of different hyperscaler implementations and those of other system providers. We add to that a dedicated 2 megabyte L2 cache, and we support up to 3.7 gigahertz in frequency. But it's not just the CPU core. We thought about the entire system. As part of the design, we've went with 96 lanes of PCIe Gen 6, which supports CXL3, which means you can attach it to any accelerator you like. It also means that you can support things like memory expansion. On the memory side, DDR5, with up to 6 gigabytes per second of memory per core, which can be sustained to each core. That is unique. That level of performance to every single core on both the I/O and the memory is unique to us in this type of a package, in this type of a performance point, at this efficiency level. And it's not just about the bandwidth. It's not just about the I/O. It's about the overall design. You see, we designed the whole thing to be low latency so that you could get to less than 100 nanoseconds of latency from the memory. We did so by sticking with a dual chiplet design, each chiplet having all of the memory and the I/O directly on it, rather than having to worry about complicated NUMA domains and multiple hops across the silicon. The result, it wasn't a typo in the slide, 300 watt TDP. 300 watts. That is amazing. It's built on a 3 nanometer TSMC process and allows for that maximum compute density. This is what purpose-built design looks like. This is what we're so proud of. The AGI CPU is breaking records all over the place for performance, for scale, and for efficiency. You saw some of that in the video. This is a standard OCP air-cooled rack. Nothing unique about it, nothing especially exotic about it, just OCP rack. Standards, right? That's our head of OCP right there clapping, just so everyone's aware. 36 kilowatts, we pack in over 8,000 of these performant CPU cores. We do so by going to a 2-node, 1U server, 30 of them. You can't do that in other systems because the power consumption is just too high. This is setting records for air-cooled. But you know what? If you want liquid-cooled, we can do that too. Over 45,000 CPU cores and a 200 kilowatt, again, a standard rack from OCP. Over a petabyte of memory in this thing. And oh, by the way, fun fact on this one, it's a 200 kilowatt rack. We actually only consume about half that much power. We ran out of space, that's why we couldn't put more cores in there. Yeah, it's pretty wild. The scale of this stuff is crazy. It's just really inspiring. These are standard racks, but there's nothing else like them. To get to this level of efficiency, you know, we really had to design the ARM AGI CPU from the ground up, and that's what I'm so proud about, and I'll tell you about in a minute. But before I get that, I want to just talk about the fact that these are standard racks, because it's not only about the fact that we are using there we go. It's not only that we're taking from OCP and leveraging some of their platforms, we're also giving back. We're in the process of making a bunch of contributions to OCP, things like ARM Server Ready, authenticated access control, and diagnostic tools. And those contributions won't just be for the ARM AGI CPU, they will apply to the entire ecosystem. So it'll make it available so that, and they will be beneficial for all ARM-based platforms, because it really is an ecosystem that we're building here. You know, ARM has always been about nurturing and partnering with the ecosystem. That's always been core to our identity. And those relationships are paying great dividends now. You saw the video that Rene played, and we're so grateful about all those partnerships. You know, it's those partnerships, actually, which have allowed us to build the ARM AGI CPU. Some of them are very long-standing. Partners like TSMC and Samsung and Micron and SK Hynix, these are partners that we've been working with for well over, for decades, literally for decades. And we've also got some new partnerships, which is why we're so proud to say that the ARM AGI CPU is available now. Says it there, it doesn't say it there. Yeah, so ARM AGI CPU is available now, and we're so proud of that. It's actually in customers' hands. Customers are actually evaluating it as we speak. We are ready to go, and we're so grateful for our partners, both on the ODM side, on the memory side, on the CPU side, on the manufacturing side, who have helped us get to this point. We'll be in production by the end of the year, and we are excited to share that with you. Today we've got firmware ready to go. We've got specifications ready to go. I talked to you about platforms. I talked to you about supply. The one thing I haven't talked to you about yet is software. Let's talk about software. Now the next slide. Okay, so you know, the reality is that ARM has been investing in data center software ecosystem for well over 15 years. I don't know if everyone understands how long we've been investing in the software ecosystem. For the beginning of that time, in the early days, it was just ARM investing in the software ecosystem. And then something happened in 2019. We launched ARM Neoverse. And what ARM Neoverse did, that compute platform, when we launched it, it allowed our customers to begin to launch products with a much lower barrier to entry. It allowed them to build their own silicon and start to coalesce around a common platform. And that started that software flywheel turning. You see, when tech leaders started adopting Neoverse, they started to optimize software around it. And the more of those tech leaders that adopted Neoverse, the faster that flywheel started to spin. Today, we've got AWS and Google and Meta and Microsoft and Oracle and NVIDIA all investing alongside us in the software ecosystem. And that really was what, you know, allowed us to kind of really make some great traction in software. Together, we've made ARM a first-class citizen on most modern software packages. And for our AI software ecosystem specifically, not only are we a first-class citizen, not only does software run well on ARM, software actually runs best on ARM. And the reason for that is very simple. For AI, the ARM software ecosystem, the ARM architecture, is the primary CPU architecture in support of AI today. In fact, the work we've done together with technology leaders means that tens of thousands of companies today run their software on ARM in the cloud on over 1.25 billion ARM Neoverse cores, which we've already shipped into data centers around the world. And that growth is only accelerating. That's actually the curve. You see, ARM in the data center just works. This is a key point. And I don't know if I'm making it well enough. So I'm going to bring somebody on stage who's got a little experience with software. Paul Saab has worked on Meta's infrastructure for over 18 years. He's one of the longest tenured employees at the company. There's a laundry list of things that he's been responsible for, including the adoption of flash storage all the way through to the implementation of IPv6. Today, he's specifically focused on making AI more efficient in their infrastructure. And that's how we got to know each other. Please welcome Paul Saab. Great seeing you, man.
Thank you.
Thank you. Thanks for being here. So, thanks for being here.
Thank you for having me.
You know, you've told me the story before, but you know, I really want to hear. You know, you guys have had a long history with ARM. It goes back longer than just a couple of years ago. Can you maybe give everybody a little bit of a history lesson as to kind of how things started?
Yeah, you know, I think it was like 2014, 2015. We were looking at ARM. You know, we were really excited about the efficiency wins that we were seeing. We were really back then just targeting our hack/PHP platform called HHVM. You know, and it was working great. Like we made it work. It was performant, and then the market kind of went away for us. We didn't really have a platform anymore, and so we just sort of tabled it, and we ripped all that code out. Everything in the code base was removed.
Oh, geez.
Yeah.
Well, okay. So that was 2014 and 2015. Obviously, something must have changed, or you wouldn't be standing here today, right? So kind of where do we go from there?
Well, the story's kind of funny. Is like it was like we were just coming out of the COVID bubble, and we had a bunch of people over at the house, you know, sitting around, socializing and whatever. And I turned to one of my colleagues and I said, "Hey, I want to port to ARM again." I kind of had this gut feeling that the ecosystem and the world had changed, and you know, if we didn't start then, we would be kind of playing catch up when it actually happened. I didn't even ask my boss here for permission to buy these machines or even to start the project.
It's a good thing he approves now.
I don't really ask him permission for much to do. So,
all right, well, hey.
But yeah, so we started we decided we found some machines on, you know, out there. I went to some other colleagues. I said, "Hey, I want to port to ARM," and he actually responded, was like, "I was wondering when you were going to ask me." So we got the machines in, started porting, you know, making great progress, but it was super slow. We only had 8 machines, but we had this vast x86 ecosystem, and I went to the guys and I was like, "Hey, can we cross-compile?" And that's what we ended up doing. We ended up working round the clock. It took us about 90 days, 5 engineers, and we had a full complete port, full system ready. But then we ran into another problem. We had no silicon to buy. And this is, and Santosh referenced this, that we looked at every partner. And I think this is about the time you and I started talking.
So you'd say the market was a little bit underserved, maybe, for what you guys were looking for.
I think underserved is an understatement.
Yeah. But let's go back to the 90 days, 5 people. I mean, really, it's okay. So I'm going to take your word for it. It was 90 days, 5 people. But that's just getting the code working. Like now you've got to operationalize and get it performant. Like how's that going?
It's still a small team. I mean, it's a lot of very devoted people bringing the systems up. From the time we finished that initial port in 2022, it took us about 2.5 years to actually get some sort of production-worthy systems in that were TCO effective, performance per watt, and it was still a very small team. And even today, it's really a small team that's focused on hyper optimizing. It started off with once those performance systems landed, it was really just one engineer until a few more came in. But that engineer never had written a single line of Neon, never written a single line of SVE, and single-handedly took some of our most precious workloads and made them work on ARM.
And how's it performing now, generally? Like on typical workloads? Like how should we think about the performance in the general?
We're seeing performance that is basically equal to anything you can buy on the market today at massive performance per watt improvements.
That's great. That's great. Okay, my light's going to start blinking in a minute here, so I'm not going to keep you on stage too long. But I just, first of all, I want to say thank you. But before I let you go, I guess one question for you. If somebody's out there thinking about, hey, because there are tens of thousands of companies that are using ARM already, but there's still a few that aren't. What sort of advice or guidance would you give them? What would be your kind of recommendation to them?
I think, small focused teams doing the port, but, like if I were starting the port today, I would be using an LLM. I mean, what I'm seeing some of the engineers that are now optimizing, even existing ARM accelerated code, they're using LLMs to, even boost those by 10 or 20%. So the barrier to entry today, like porting to ARM, is, I would say, close to zero, because like the LLM is just going to do it for you. I don't even write any handwritten code anymore myself. It's just all LLM, all test cases, all across the board. So like there's no excuse to port to ARM today.
Excellent. Thanks, Paul.
Thank you.
Thank you. Well, that was inspiring. I mean, you know, Paul and I have obviously known each other for a little while, and you know, the tenacity and what I hear around is, you know, once Paul gets something in his mind, it just kind of happens. So I appreciate all the support, Paul. Thank you. We're so part of the partnership that we've had with you and with Meta more broadly. So thank you very much. You know, what I love about that story is that they had a need. You know, the market was underserved, and together we worked together to go address it. The reality is the opportunity for the AGI CPU is broad. The software is ready, and we have a great product. And that's why we're seeing such great customer traction. We're seeing it in multiple areas. If you think about companies like Cerebras and Positron and Rebellions, they're joining Meta and OpenAI by using ARM AGI CPU for things like managing head nodes that they're building or managing accelerators they're building, so head node type use case, or also for agentic orchestration and fan out. These are specific use cases that they're looking at. And then in the cloud, you know, we see companies like SAP and SK Telecom and Cloudflare who are actively using or planning on deploying ARM as part of, you know, their infrastructure. These are just a few of the customers that are planning on using ARM AGI CPU. But rather than me tell you about what they're doing, let's listen to them.
ARM's been building IP for hardware for generations. Over the last decade, built processors for heavier weight compute.
Cloudflare is one of the largest networks in the world, and ARM is a really important part of our ability to keep innovating, not just at the speed we've always innovated at, but a speed that keeps up with what's going on.
ARM has consistently delivered predictable scalability and excellent power efficiency.
How can we drive more energy efficiency at the end of the day and more scale through what we are running and deploy? Also having an eye on, from a price performance perspective, on cost reduction overall.
One of the key criteria for our customers is the best use of the limited energy available for them. Getting the technology that gives them the best outcome per watt is critical.
Data centers have an obligation in the AI ecosystem. We use a lot of power. This is where ARM has been a leader historically, and ARM AGI really separates itself.
AI has fundamentally turned our business upside down. It grabbed all the available data center capacity to the point where they're building many new data centers are coming online, which then puts pressure on power delivery into those data centers.
And ARM technology gives them the most outcome per watt.
The AI industry isn't the largest industry in tech. It might be the largest industry in the history of tech.
There is a big excitement about the ARM AGI CPU. This is helping us to accelerate the innovation as we are moving into the future of AI-driven enterprises.
AI is redefining the entire infrastructure from the user, the consumer, the business, the use cases, the models, the applications, the infrastructure, all the way down to the silicon.
Many of the solutions out there are getting power hungry. Not all customers, their data centers today can handle that. With the ARM silicon coupled with a brand new line of AI accelerators, we now have a power efficient solution that we can offer our customers.
This performance per watt that we're going to be able to get out of this CPU is really going to help us not only save money, but be able to get to places that would have been harder for us to get to.
So what makes this partnership compelling is the system level combination. SK Telecom is pairing the ARM AGI CPU with the rebellious AI chip. This CPU is the perfect fit as we evolve into an AI data center developer.
The ARM AGI CPU strengthens the orchestration layer of the system, enabling greater efficiency in the head nodes that support next-generation frontier AI systems. We are excited to work with the ARM team and continue building the infrastructure that powers the next wave of AI.
There's a lot of change happening right now, and it's interesting to see how that drives innovations on all levels. It opens up a whole new world of possibilities to drive innovation. That's pretty exciting.
Our mission is smarter technology for all. And so to be able to be at the front end driving AI platforms and solutions, who better to partner with than ARM?
This partnership is not about what's coming next. This partnership is about the decade to come.
I just want to say thanks again to all of our customers and partners that are supporting us here today. The support we've gotten has really just been incredible. We built ARM AGI CPU for you, and we're so pleased with the response. You see, ARM AGI CPU has been designed from the ground up to make sure that performance scales and power stays predictable. That's the superpower: performance, scale, and efficiency. And it's resonating with our partners. You see, that's a very different approach than is taken by x86. They've burdened their execution, they are burdened with execution overhead and legacy feature support. They chose to focus on things like modularity, support for lots of different markets and esoteric use cases. We are ruthlessly focused on improving efficiency and reducing latency. Ultimately, this is about architectural philosophy. We're not strapped to the past. We are not strapped to the past. Listen, we don't support Lotus Notes, okay? We just don't do it. We're focused on exactly and only what the AGI data center needs: performance, scale, and efficiency. Let me take you through that in a little more detail. It starts with performance. And performance for us is all about doing more work for every clock cycle. This has always been an area. Great IPC has always been an area where ARM has shined. How much work do you get done every single cycle? Our AGI CPU absolutely shines here. Now, what we see is that legacy CPUs, they sometimes try to compete on this vector by doing things like increasing the frequency, going to boost modes. But here's the reality. When you increase the frequency, what else do you increase? Power. That's a problem. These boost modes are not sustainable across long periods of time. They're not sustainable across a chip. With ARM AGI CPU, what we give you is full performance sustainably all the time. And ultimately, that means scale. We linearly scale across cores, and our memory and I/O subsystem is specifically designed to be matched to those cores so that we can continue to feed them 6 gigabytes per second of memory bandwidth to every single core. In order to scale, what we see some of these legacy architectures do is multi-threading, right? What happens when you do multi-threading? You throw 2 jobs at the same core. That's how they get to a high thread count or try to get to a lot of devices. But the reality on that is your I/O and your bandwidth, that doesn't double. So you've just moved the bottleneck elsewhere. And oh, by the way, the CPU needs to be burdened with managing that back and forth. And so your performance degrades. You end up starving your processes. What we see over and over again is that data center operators have to over-provision their data centers by 30% or more to deal with this lack of nonlinear scaling. This is an actual thing that happens. We take pride in not having to do that. There's actually a great demo of this out on the show floor. I encourage you all to check it out after the keynote. And then finally, we have this maniacal focus on efficiency. Obviously, that's always been that's always been ARM's hallmark. It's always been something that we've been great at. We're leveraging all those techniques and methods and experience that we've built up over the decades around building incredibly efficient processors, incredibly efficient technology, And we're packaging that all up in a custom design specifically for this use case. AGI CPU is purpose-built without that legacy overhead because it all comes back to performance, scale, and efficiency. That's my efficiency bullet. At the end of the day, no wasted cycles, no stranded compute, no wasted power or silicon. And we're super proud of that. Let's look at what it means in practice. I'm going to show you the results, and they kind of speak for themselves. First, let's talk about sustained performance. What you see here is the performance that you can expect to achieve consistently. So this is consistent performance. No performance throttling because you're over power budget, no memory or I/O contention. This is the sort of performance you're going to see. You can see with AGI CPU, it's world-class. You've got world-class performance you can take to the bank. Next, let's talk about scale. How many threads or agents can you run in each rack? How much compute do you actually support with a fixed power budget? With a fixed physical footprint. Remember those racks I showed you earlier? There you go. That's where we land. And of course, there's efficiency. Performance per watt. So what you're seeing here, these are all of these charts are with SMT disabled. So these are single-threaded cores for us, single-threaded cores for them. So no multi-threading whatsoever. Okay? I told you what I thought about multi-threading, which is why we elected to show it to you this way. But oftentimes what we hear is that multi-threading is going to improve that middle chart. It's going to allow for more scalability. Multi-threading is going to improve the performance per watt. Let's take a look at what happens if we turn multi-threading on. Okay. See, first of all, your performance goes down. That's the chart on the left. And the reason why the performance goes down is because you can't just add more work and expect performance to be the same. So that's pretty self-explanatory. And in this particular case, again, we've held it at kind of, based on the memory and the I/O bandwidth available, kind of where you land. That second one, the sustained threads per rack, the reality is that because of the limitations on the device and all of the bottlenecks, you end up in a scenario where you can't actually use all of those threads. Many are left idle. And then finally, performance per watt. Yes, there is a small improvement there, but not enough to change the calculus. At the end of the day, the results are clear. This is a killer product, and ARM is a class of its own. Performance, scale, and efficiency. I'll say it one more time. This is what the ARM AGI CPU is built for. And the impact on the AI data center is going to be profound. Let me turn it back to Rene. Thank you.
Thank you, Mohammed, and thank you, Paul, and your LLM agent that's going to do all the conversions for us. So we've shared a lot with you today, and I'm grateful for your patience and time. If there were just a few things to take away from this morning, I think it starts here. Performance per watt, which translates to performance per rack. When you look at an x86 equivalent structure, same power delivery, 36 kilowatts, 2 times the performance in the same power. That's what you need to remember. For those of you who are paying for that power, here's another number you need to remember. If you think about 1 gigawatt of capacity, and you think about the CapEx associated with that extra power you're spending at the sake of performance, it's up to $10 billion of CapEx. Obviously, these are serious numbers. So again, the takeaway from the ARM AGI CPU is 2 times performance per watt, probably more than 2 times, ish. Now, you heard a number of comments in the videos, including Santosh, that when you embark on the kind of engagement and partnership we're talking about, while a day like this, an event like this is wonderful and amazing, and we're talking about a great product, it's really not about the day, but it's about the future and commitment to a roadmap. So we are committing to future generations of this product. ARM AGI CPU 2 is coming out soon, as is ARM AGI CPU 3. As you heard in the videos again, these are multi-generational engagements. We are investing a lot. Our customers are investing a lot. The ecosystem is investing a lot. We are absolutely committed to a roadmap and a future around this product line. In addition, we will continue the CSSs around these products. And as Mohammed mentioned, one of the big benefits of the CSSs are the speed it allows our customers to get to market. It also enables a lot of benefit for us as well. So the CSS roadmap will continue. So I want to close a little bit around what we think the financial opportunity is for ARM. So before this day, our business has been IP and IP compute subsystems, and we have been doing extremely well in that business, far better than what we had talked to investors about 2.5 years ago when we did our roadshow for the IPO. We're actually ahead of that. When we look at the AI data center business, that represents today about a $3 billion TAM, and now I'm just talking about roughly the royalties. So I mentioned on one of the earnings calls that the cloud AI business will probably be our largest business in a few years, and this is really driven by all of the growth that Mohammed talked about, the deployment of 1.25 billion Neoverse cores and forward. When we think about our business going forward, the ARM AGI CPU, and as Mohammed mentioned, we have committed customers, Meta, OpenAI, Cloudflare, SAP, F5, customers you saw in the video. When we think forward about what is the market opportunity for this business, it is a dramatic sea change for the opportunity. When we look at what's going on with agentic AI, the growth of CPUs, the benefit that power-efficient CPUs bring to the data center, we think this represents about a $100 billion TAM for us in the future. So today is all about the ARM AGI CPU. But there will be some tomorrows. And don't ask me about tomorrow today. But there will be some tomorrows. And we think this opportunity to take the work we've done across all of the markets, as you've heard in the video, from edge to cloud, from milliwatts to gigawatts, we think we have an opportunity to address greater than a $1 trillion TAM by the end of the decade. So we've got some work to do, but I couldn't be more proud of what our company's achieved, grateful to the ecosystem that helps us achieve it, and the customers that are now committed to buy our product. I want to close by saying that we stand on the shoulders of our ecosystem. None of this is possible without the ecosystem that we have nurtured for 35+ years, many of you who are here today and watching on video. Thank you for attending today. ARM is everywhere, and we appreciate your support. Thank you. Over 350 billion chips have been shipped with ARM. We're the most pervasive computer architecture ever invented.
We touch 100% of the connected population. Anyone with any digital device is likely using ARM.
ARM is one of the great secrets of the technology space. People use ARM technology every day, multiple times.
When you look at the ARM ecosystem, it is the de facto platform that everybody is building on top of.
We deal with an immensely different range of different companies. In some cases, they take our compute subsystem and put their technology alongside that. But an increasing number of partners are saying, actually, we're not experts in building silicon. We would like to have an ARM-based solution. We chose for many years not to build silicon because really, ARM is all about what our partners want, and that gave us the IP business that we've got. That will be continuing an important part of what we do going forward.
So the IP and the CSS roadmaps remain unchanged. We get this tight coupling of lessons that we learn from doing silicon development that feeds back into the current generations of IP development, which the whole ecosystem, however they engage with ARM, will benefit from.
And it's all about choice. And it depends on where the ecosystem is at and where customers want to engage with us around that.
And the ARM silicon will combine all of the goodness of all of our technologies, and it's got enhancements to scalable vector extensions that allow you to provide higher quality computing for AI as well.
AI is moving incredibly fast. I think every day you wake up and there's a new technology around AI.
Think about where we're going to be in AI 20 years from now. And then think about the fact that everything's growing faster today than it was 20 years ago.
The world is evolving to adopt AI, and so more and more what we're seeing are these optimized systems, these optimized platforms. That is the perfect home for a product like the ARM AGI CPU.
In the era of agentic AI, the ARM AGI CPU was really purpose-built for these agentic AI workloads, and specifically for AGI in the future. So that's really how this brand will really stand up.
So as we've learned with AI, we're starting to learn more and more about customers' workloads, their applications, what they need. And what we're finding is that the AI solutions today are very, very power hungry.
Power reduction is a constant battle, and ARM has an architectural advantage for getting more performance at lower power.
The product was designed to run on batteries, which is why the product is so pervasive. But any CPU is only as pervasive as the software that runs on it, and that's really the ecosystem.
Compared to the other processors that are out there today, ARM has power efficiency. It gives customers options that they don't currently have today.
ARM AGI enables a true dual-socket server that we can fit into any existing air-cooled data center. And it represents a focus on efficiency that I think we've lost. And it also is a focus on performance.
I'm excited about these new ARM silicon-based systems because it allows customers to have more choices. And we do believe that this is going to be a game changer.
It's amazing to be a part of bringing this technology and the value and the benefits of this technology to as many people as possible.
For ARM to build its own silicon, the first thing we had to understand is what our customers go through to build their own versions. There's a bunch of things that you have to do that we kind of knew about, but now we understand much better.
We really focus on really robust, disciplined design practices, and the team has really stepped up. The amount of dedication, just all-in buy-in for this project has been just outstanding. You know, for me to be a part of this team, to work alongside many of the people that I see, you know, working hard in the labs at night or putting in their all to kind of solve that late night issue, that's an incredibly rewarding experience.
And when the silicon came back and it worked and it's up and running and the software's running and the team's excited and we ship to our customer and our customer has it up and running, the feeling's absolutely amazing.
I remember the email that I got saying it's alive. That was a wow moment. It meant that I could ping the CEO and say it's alive. The wow moments won't be just one. It's just going to be a series of them every other week.
To build a world-class product like the ARM AGI CPU, it takes a lot of people, a lot of resources. And we didn't do it overnight, but we did it pretty quick. That's the way you have to do things in this market today. Speed matters, and I couldn't be more proud of the team to make it happen.
I look at this as a chapter in a long novel, and we're just getting started. It's going to be groundbreaking.
And I feel immensely proud to have worked for ARM and to work with some amazing people to achieve that transformation to the company, but the transformation to the industry and to the world.